My name is Marianne Hakes, and I work with explorations on aging in College Park. And for those of you that are new to Corridor Conversations, we are several of the local villages on Route 1, Hyattsville Aging in Place, University Park Helping Hands, College Park Neighbors Helping Neighbors, and Exploration on Aging. And we've joined together to do Zoom conferences to keep people entertained, engaged, educated, ideally for all ages, but because of what we do, focused particularly on older people. But we plan to continue this, and we will probably continue it on Zoom for the next foreseeable future. And actually, let me just mention our next one in August is called Scattered Clouds, Finding Poetry in Washington, D.C., and that will be on Saturday, August 28th from 2 to 3 p.m. So you'll get more information as you normally do through the email. Today, I want to thank Maryland Milestones and the Anacostia Trails Heritage Area. They have given us a grant, and they're helping us support these programs. So we are grateful to them. And we are grateful to Doug Hamilton, who is a College Park neighbor, eminently qualified to give this lecture. His interests are in planetary science, orbital dynamics, and the origin of the solar system. He was a co-investigator with NASA's Jupiter mission to Jupiter and collaborated with NASA on the Horizon mission to Pluto. And as you heard, he is still working with NASA, but teaches graduate students for a living. He himself is a graduate of Stanford University and received his PhD from Cornell and has taught at Maryland for at least 20 years. So go, Doug. So Doug's going to talk to us today about Pluto, planet or not. And I think we would appreciate your holding your questions unless you have something that's absolutely germane to where Doug is in his talk, something you don't understand, or something. Feel free to put it in the chat and we'll direct it to Doug. So I'm delighted to present Doug Hamilton to you.
Wow, hey, thanks, Marianne. Thanks, everybody. Let's see. So on questions, I think anytime put a question in the chat, and then Marianne can decide whether to hold it till the end or whether to bring it up. I do like questions. It keeps the speaker honest. Lets me know that you guys know what I'm talking about, or if I'm going too fast or too slow. So do ask questions. These Zoom meetings are particularly difficult. They're very one way, and so the questions are important. So I have a lot of Pluto material I could talk about, and so I kind of took a little bit of this and a little bit of that, and I put it together as a timeline so to tell you Pluto's story through the past 90 years from its discovery until today. And so along the way, it's sort of a personal journey because as many Pluto results I could talk about. I could talk all about the spacecraft flyby of 2015. But I've picked and choose the things I found interesting and I've worked on myself. And so there'll be, at the end, if there's particular things that interest you, there's a lot of directions you can go with questions. So here is the discovery image for Pluto. And so you can clearly see it over there on the left. So luckily, it was hard, it was difficult to find Pluto, but thankfully there was this little arrow here which pointed it out, which made it easier to find than had the arrow not been there. But the way it was found was to take this image on January 23rd, 1930, and a week later this image was taken. And you can kind of look back and forth, and this pair of stars, you see my cursor actually? Can you see the little arrows? Yeah, good. Okay, so this pair of stars up here is this pair over here. And you can see the images are a little bit different, but those match up, and this big one matches that big one. And we go way down here, this guy here matches, there is that one's right here. And so right above that star is a little tiny little dot, one of the faintest things you can see, but it's different than all the other stars because over here it's gone. So that's where it should be. That's where it is right there. Here's where it should be, and it's moved over there. So Clyde Tombaugh, who discovered Pluto, recognized that this thing disappeared and this new thing here appeared. And then he followed it over the next several weeks, and it's a moving star. So it's a planet. It's a little planetoid out there on the edges of the solar system, far away, moving slowly. So that was a discovery image in 1930. And let's see, go forward. Oh, I got to click to go forward. Okay, so this is just for you. That's not a very good image, but this is to tell you where Pluto is located. So it's one of the furthest objects. It was the most distant planet for many, many years. It is no longer the most distant planet, but we'll come to that. It's out here. It's 30 or 30, more than 30 AU. AU are the astronomical unit. That's the distance from the sun. 1 AU is the distance to Earth. So Earth is way down here, kind of right where the U is in sun. And 10 times the Earth's distance, that's where Saturn is. And here's Neptune at 30 times Earth's distance. And Pluto is the blue orbit. It's kind of elliptical. You can see it's not a perfect circle. And so it's mostly outside of Neptune's orbit. Occasionally it crosses inside like this and then crosses back out again. So that just happened, oops, that happened in just before the year 2000. I crossed back out and became the most distant planet again. Pluto is named, for my next slide, it's named for the god of the underworld. And so there is Pluto. That's his graduation image. So, he had just graduated. He was a young man full of promise, had a clean shaven, well, not clean shaven, but a tidy beard. And he was going off to do great things. Little did he know he would end up as god of the underworld. So it was wine, women, song, debauchery, and there he is 10 years later, no longer the fine upstanding citizen. He's hanging out with demons in the underworld. So Pluto's named for the god of the underworld. And we're going to talk about moons of Pluto, and they're all named for objects or for characters that have a connection also to the underworld. Not much happens for 50 years, 1930 to almost 1980. So Pluto is so far away, it's so small, it's difficult to detect it or to study it. And the telescopes, at the time, we didn't have good cameras. We were using film still. And so basically it was just too difficult to really study Pluto and learn much about it. This pair of images, it's actually 2 images again, like the last time. Here's Pluto in black, it's a negative, and here it is again. This is a discovery of Pluto's huge moon, Charon, in 1978. Everybody see it? See where the moon is? No, it's pretty hard to see where the moon is. So that's the moon. See this lump? See here, this is a nice kind of circle for Pluto. And this is kind of a circle with a lump on it. And so, if you just saw these 2 images, you'd never know that that lump is a moon. But again, you watch this over many days. Charon takes 6 days to go around Pluto. So there's a lump, and then 3 days later, the lump goes away. And then 3 days later, the lump comes back again, or maybe the lump's down on the other side. And so this repeats. And that's what they were able to look at images with this quality and convince themselves that they discovered a new moon for Pluto. And this is a great time for Pluto in its life, because this is one of the largest moons in the solar system. In fact, it is the largest moon relative to its planet. It's fully half the size of Pluto. You wouldn't know it from just this little lump here, but Charon is half the size of Pluto. So quick question to the audience. There's which planet has a moon that's also has a really large moon compared to its size? It's actually the second in the list of largest moons. Anybody know? This planet has a moon that's a quarter the size of the planet. What planet is it? Yeah, I see it in the chat window. If you're curious, check out the chat window. It's Earth. So Earth actually is unique by having a moon that's incredibly large compared to the parent planet. Jupiter has moons that are bigger than our moon, but Jupiter is huge. So these moons are tiny compared to Jupiter, whereas our moon is large compared to our planet. So there's Charon. This is 1978. Now things move fast now, because in 1978 and in the 1980s, we're getting digital cameras. And so this revolutionizes astronomy, because these are still film images. You had to put the camera at the end of the telescope and open the exposure and expose it to space, collect the light, and developed the film, we actually invented digital cameras, and we launched a telescope into space. So many of you probably know the Hubble Space Telescope. It's still up there, it's still working. So this is 1978. Hubble goes into space, I think it's 1990, maybe it's 89, I think it's 90. And one of its first images was to look at Pluto. And we go from this, Pluto and Charon over here, to this. So that is the Hubble Space Telescope image of the two objects in 1990. So there's Pluto, and Charon is no longer just a lump on Pluto. It's an independent body, and it's separated. And you can see that the light is almost as bright. This one is twice the size of this one. And so the brightness of the smaller one is getting close to that of Pluto itself. And so you also probably remember, most of you were around to know that the Hubble Space Telescope, they made a mistake with its optics. And so the image was blurry. And so Hubble needed glasses, needed to have its vision corrected. And so there was a servicing mission. We launched a space shuttle up into space, rendezvoused with the Hubble Space Telescope, and put on this corrective lens to fix the problem with the optics. And so that was just a couple of years after 1990, and this image quality goes up to that in 94. So that's the corrected Hubble Space Telescope image. So, I mean, this was already a huge improvement over ground-based imaging, and then correct the optics. And this is what Hubble can do today. It can do a lot better today, actually, but this is the promise of Hubble back in the early 90s. Okay, so then again, Pluto and Charon, you can tell which is which by the relative brightnesses. All right, so Charon, what is Charon named for? Charon has to have a connection to the underworld, and Charon is named for this gentleman here. He's the ferryman ferrying all the lost souls over to Hades, Pluto's domain. And so you can see he's not a very friendly guy. Here's all these lost souls beseeching him, please, please don't take my daughter. And he's just like, oh, doing my job here, sorry. So Charon is a kind of crusty old guy, and he takes the lost souls over to Pluto, over to Hades. All right, so there's the underworld connection. We go forward from 1994, 10 years, and this image is taken. So this is Pluto and Charon again with the Hubble Space Telescope, separated. They're kind of blurry and smearing together because they've exposed the image a lot longer. So the light from both Pluto and Charon has, overexposed those two bodies. And what this is done to pick out any faint objects in the environment. We're looking for moons. 2005 was right before the launch of the Hubble Space, or the New Horizons mission to Pluto. And so on the team, we wanted to know, what's there, what can we study? If we discover things now, we can study them with the spacecraft when it gets there in 10 years. And so this was a moon search, and there's a lot of blank space. Here's some diffraction spikes and issues with the optics of the telescope. You have to correct for all that, and but then here are these little dots, and those little dots are independent moons orbiting Pluto, and they originally were given provisional names, but eventually they were named Nix and Hydra. And so they were discovered by the New Horizons team. And so Nix and Hydra have to have connections to the underworld. But so I'll tell you who Nix and Hydra are in a moment, but if you'll notice, Nix and Hydra, the initials NH, match the initials New Horizons, the spacecraft that's going there. So that was done deliberately. So Charon, that was when you discover a moon in the solar system, you get to name it. And so the guy, Jim Christie, the scientist who discovered Charon, got to name it. And so Charon is actually correctly pronounced Charon, the ferryman for the dead. But Jim Christie's wife was named Charlene, and he wanted to name the moon after his wife. And so he mispronounced Charon. He called it Charon, short for his wife, Charlene. So he kind of snuck that in. So the New Horizons with the N and the H, Nix and Hydra, they sort of snuck that in as well. So you have to name things for the underworld, but you can also have a personal connection in there. So any questions for anybody? I also will stop with questions because it is nice if you guys have questions so far. Anybody? I'll ask again, so don't have to have something now. All right, so moving on. There is Hydra. Where does Hydra come from? So Hydra is this mythical beast with all the heads. And there's Hercules. He's the hero, and he's fighting the Hydra. And so fighting the Hydra is just not something you want to do. So you can look over my text here. Each time you cut the head, it had I think it was 9 little snake heads here. And each time you cut one off, 2 of them grow back. That sounds kind of bad. And its breath is poisonous. And it's got one head that's immortal. And so and you don't pick a fight with Hydra, but Hercules did. So there he is fighting the Hydra. The connection to the Underworld here is a little bit loose because Hercules later visited the Underworld. So he fought the Hydra and he visited the Underworld. And so that was close enough that the Hydra got accepted as a name for one of Pluto's moons. Nyx is named after the goddess of night. And it's spelled Nyx, and we spell it, for Pluto, we spell a new moon Nix because there's an asteroid that already has this name. So we want to distinguish it. But it's named for the goddess of night, and she turns out to be the mother of Charon, who we've already met. And so there's a connection also to the Underworld. All right, and so you might have asked yourself at this point, how does this young babe here have this crusty old guy as her son, right? That is his mother, Charon's mother. And so there is an explanation here. I have to take you through some genealogy of the ancient Greeks here. So the real question is, how did this come to be? And you have to know Charon, you got to know who's his daddy to make him look like this. What happened? So we can go on into the genealogy books and we find out that Erebus here, Erebus is the father to Charon. So that still doesn't explain how the young girl could have such a crazy looking older guy for a son. But there's an answer to that as well. There's another relationship here, which I'll show us some more arrows. These guys are brothers and sisters. So that, I think, kind of explains it all, right? All right, so everything's great for Pluto at this point. Pluto's, it's got the biggest moon relative to its own size in the solar system. It got a couple of small moons discovered as well. And this is what you also remember. So in 2006, disaster strikes and Pluto is stripped of its planethood by the International Astronomical Union, meeting in, I think, Czechoslovakia. And this is the most unpopular thing astronomers ever did. They just decided that, well, okay, Pluto doesn't deserve to be a planet anymore. We're going to call it a dwarf planet. And there's good reasons for this, but it was not very popular. And so the astronomers had a image issue on their as a problem after this. And so this little image here shows Pluto. This is all the planets, sitting around the Thanksgiving dinner table, and here's Pluto at the kiddies table with the little juice box. So Pluto no longer gets to sit with the other planets. But if you look at the size of these planets, that's actually explaining why it was done. So personally, we can talk at the end whether Pluto should have been stripped of its planethood or not. My own opinion is that I think it could have been grandfathered in as a planet. I mean, after all, it was a planet for 75 years. People got used to that. Why change it? But the reason they wanted to change it is there are 4 giant planets. There's Jupiter, Saturn, and Uranus and Neptune. These are gas giants, and they're huge. And then there are 4 terrestrial planets, Earth and Venus and Mars, Mars and Mercury. And then Pluto is much, much smaller than all these other ones. And so it doesn't actually fit in so well. And also out in the outer solar system where Pluto lives, we've discovered other objects, about a half dozen other objects that are about the same size as Pluto. So Pluto, it's a planet because it was discovered 75 years ago. Since then, we've discovered other things as big as Pluto out in Pluto's realm. And these objects, the new ones, don't get called planets. And so, your question is, if we had discovered everything today, we would never have named Pluto a planet. So the question is, do you grandfather it in, or do you reclassify? So the astronomers chose to reclassify. We got hate mail. Got lots of hate mail from 6th graders. Hate mail from 6th graders just is not something you want to get. Okay, so what do we do for poor Pluto here? So here's a T-shirt. People are trying to show their support for Pluto, and there were camps trying to save Pluto. And so Pluto's now just not very happy. So we have to actually try to lift Pluto's spirits and make it a happy planet or dwarf planet again. And this is actually a Route 1 corridor. The Route 1 corridor decided to take action and help Pluto. And so would you like to know what the Route 1 corridor did? What we did is we used the Hubble Space Telescope again, and we looked at Pluto, and I'm involved in this. So this is my colleague Mark Showalter and me in 2011. And we said, maybe there's some more moons there we could give to Pluto. And so we looked and we processed the data very carefully, and we got to discover some new moons. So this is a discovery image for a moon. I got to name this one. I named it P4 because I'm not very imaginative, but Pluto has 3 other moons, and this is the 4th moon of Pluto. And so you give it a provisional name until that the International Astronomical Union, so you can give them an actual option for names, and they can approve it. So this is the discovery image. What's been done here is we've put a filter across Pluto and Charon to block out something like 99% of the light or 99.9% of the light. So Pluto and Charon look really faint because there's this huge, almost opaque screen in front of them. And what that does, again, here's the artifacts we saw before. Here's Nix and Hydra. And they look almost as bright as Pluto because they don't have the screen in front of them blocking the light. And so then here is P4 and over here as well. And you can see it's moved. And it's tiny, it's definitely something, but it's a lot fainter. It's a lot smaller than the other objects. And so we, as the discoverers, Mark Showalter and I get to name it. And so this is really exciting. What are we going to name? What are we going to name Pluto? And what we decided to do, we decided not to name the moon ourselves. What we decided to do was have a contest. Oops, let me see. I'm sorry, I skipped something here. Contest is coming. A year later, in 2012, we did the same thing. And you can see here again, Pluto and Charon, there's the P4, and here's the imaginatively named P5. So that's the 5th moon of Pluto. So these 2 guys were discovered about a year apart. And so in the same data set, actually, it's just we reprocessed and looked more carefully. And so we get to name them. And so we decided, this is what I wanted to show. We decided to run a contest on the internet and let the public choose. And so what we did is we put out here, we solicited names from the public, and we put a bunch of our own in here as well. And again, this image isn't so nice, but all these guys, you might recognize some of the names. I'll point a few of them out, but all these names here have connections to the underworld. So Cerberus is that's the 3-headed dog that guards the gates to hell. So that's pretty cool. There's Erebus. We met Erebus already. Obol here. Obol is the name of the coins. So not only did you, as a damned soul, not only did you have Charon ferrying you across to the underworld, but you had to pay him. And you paid him with Obol, these coins. That's all he would accept. What happened? I do not need that. I lost, do you guys lose my image? I lost my image. Let's open it up again. Ah. That's weird. There we go. All right, everyone see it again?
Yes.
Yep, we're good. All right, we're good. All right, I was telling you some of the names. That's the coin. Persephone, that's the pomegranate seed. Styx, we'll talk about Styx, and so on. So these different names. Persephone was actually my favorite name. And so the reason Persephone is my favorite name is my wife's name is Stephanie. And so I thought we should name the moon Persephone and then mispronounce it just like Jim Christie did. I pronounce it Persephone. But so that's what I was hoping for. The public suggested the name Vulcan from Star Trek. And so now we have the internet, and what's going to happen? And so the voting comes in, hundreds of thousands of votes, and boom, there it is. And so Vulcan, the Star Trek planet, won by a long shot. And it makes no sense. And we were all hoping it wouldn't be Vulcan because Vulcan is supposed to be a hot desert planet, not a cold planet at the far reaches of the solar system. There's my Persephone, it did pretty well, it came in 4th, but the 2nd and 3rd beat out by Cerberus, the 3-headed dog, and Styx. So Vulcan and Cerberus were the names we put forth. fourth for the moon names. And so it's, this was my feeling after this result came in, because we had kind of promised we were going to name it whatever the public wanted, and the public wanted Vulcan. And so this was my response. No! But there was still hope, because the IAU, the International Astronomical Union, has to approve the name. And so they came back and they said, Vulcan's not good enough. We're not going to use Vulcan. It had a use in astronomy already, as well as being, a desert planet. So they nixed that idea. So that's good. So we went to our second and third choices here, Cerberus and Styx. And so that's Cerberus. We changed it to Kerberos because Cerberus was already taken by an asteroid. And so there he is, a three-headed dog. He's connected to Hercules. The 12th labor of Hercules was to go and capture this dog and bring it back and show it off around the world. Pretty tough looking guy here, 3 heads. You got to watch out because you can get bitten from all directions. So, but it really matters for Kerberos, it really matters what breed he is. It never says in the Greek dramas what the breed of Kerberos is. And so, this guy looks really scary and you wouldn't want to meet him in a dark alley, and you wouldn't want to be a mailman at the house where this guy lives. But this one doesn't look so scary. This is a 3-headed golden retriever. That just looks so fuzzy and friendly. So it depends on what the breed of Kerberos is. If he's a Rottweiler or a Pit Bull, then he probably is scary. But if he's a golden retriever, not so bad. All right, Styx. Styx is named after a river nymph. And so there's I forget the connection here to, there is a connection to, let's see, do I have it? I forget the connection to the underworld, but she has a connection to the underworld. And so this then is where we stand as the spacecraft approaches Pluto. So we have Pluto and Charon, and we have 4 little moons that surround the pair of these. This is sometimes called a double planet because the moon is half the size of Pluto itself. And so you can see Nix and Hydra, which were discovered in 2005, and Styx and Kerberos, these little small ones, discovered in 2011, 2012. And the spacecraft flies by us in 2015, and we're able to get pictures of each of these. And so that was actually exciting. It's the quickest time from a discovery to actually having a picture from a spacecraft. There's only 4 years for Styx to go from a point of light in the sky to a picture from a spacecraft. All right, let's see. So I'm going to summarize what I'm going to kind of take a tangent here, and we're going to follow New Horizons for a little bit. Let's see. So New Horizons this is a spacecraft that was launched in 2006 from here, and it flew by Jupiter a year later, and it just flew straight out of the solar system, and it rendezvoused with Pluto in the summer of 2015. And so Pluto has this gold-shaped orbit, a gold orbit here that's sort of tilted relative to the other planetary orbits. That's another reason why Pluto just doesn't fit in as a planet. All the other planets are on fairly circular orbits that are in the same plane, and Pluto's tilted extensively out of that plane, and its orbit's not very circular. So that was the 2015 flyby, and then off it's gone. It just flew right past. It was going so fast we couldn't stop, and off into the Kuiper belt. And the Kuiper belt is where these other Pluto-sized objects live. So there's a whole lot of them out there. It's like the asteroid belt, but the objects are made of ice, and they're much further from the sun. And so in 2015, the Pluto goes from a point of light in those Hubble Space Telescope images to this set of pictures here. There's Charon, and there's Pluto. And so just gorgeous images. You'd have to be living under a rock if you didn't see these. 5 years ago, it was all over the media, all over the world. Everybody loves Pluto. More t-shirts were made. So Pluto has a lot of interesting features we could talk about. So there's this bright icy region. It's an ice cap. And so I can talk a little bit about that. I've actually written a paper about that and how it forms. Here's Charon. Charon has its North Pole is red. So there's a paper that describes how that works. So we understand why the pole is red, and we understand why this ice cap is there. Let's see. That's a close-up. So I mean, just spectacular images. And we look closely at this ice cap. You can see that it breaks up in little cells. You can see these little sort of polygonal cells, like mud that's cracked. And so we actually understand where those come from. And so this entire this is an ice cap, but it's not made up of water ice. It's made up of nitrogen, mostly. And nitrogen freezes at, I think it's 77 degrees Kelvin. So it's several hundred degrees, negative several hundred degrees Fahrenheit. So it's extremely cold. You have to be extremely cold before nitrogen will freeze. And even at Pluto, it's got a thin atmosphere made of nitrogen. So much of the nitrogen is frozen onto the planet's surface, but a lot still is in its atmosphere. So nitrogen is like water on Earth, where you have a lot of it in the oceans, and you have some in the atmosphere. So Pluto is the same. We have a lot of nitrogen in this ice cap, but some in the atmosphere as well. And so these polygonal cells, it's warm enough that the ice will vaporize and go back into the atmosphere sometimes. And so underneath this ice cap, it's warm, and it's warm enough that it doesn't melt the ice, but it causes it to flow like a glacier. So a glacier will flow down a mountain on Earth very slowly, but the ice is mobile like that. And this thing is mobile as well. It's convection. The hot ice at the bottom will slowly rise, and the cooler ice out here that's exposed to space will sink down towards the center of the planet, and it'll convect just like boiling water. So it's called solid state convection, because unlike boiling water, which is a liquid where the hot water from the bottom comes up to the top of the pot and breaks and the cool water goes down, that's what boiling is. Here it's a hot solid rises to the surface, and a colder solid slowly sinks back into the interior. And so you want to think of, again, like a glacier flowing down a mountain. It's a solid. You look at it, you don't see it moving, but you come back a few years later, and the ice has moved. The same is going on here over long time scales. All right, so there's a mystery here we can come back to if you want. Ice caps. So there are 5 ice caps in the solar system that we know about. So Earth has 2. We've got a North Polar cap and a South Polar ice cap. And we look at Mars, it's got North and South polar caps as well. For Earth, it's frozen water. For Mars, it's mostly frozen carbon dioxide, right? The same thing that leads to global warming on Earth. It's an ice cap on Mars. And Pluto is different. So first of all, it's nitrogen. And the ice cap is at the latitude of Florida. But it's at 30 degrees north. So what's an ice cap doing in Florida? That's the question for you guys. We're going to follow New Horizons now as we leave Pluto, and there's a destination, a next object. We called it Ultima Thule. That's the old name for Greenland, furthest known land. And this was a Kuiper Belt object, and the flyby was 4 or 5 years after the Pluto flyby. So we discovered this asteroid. The New Horizons team found this asteroid just in time to divert the spacecraft to go visit it. And so this is a worldwide effort using lots and lots of telescopes to actually look in the region of space where New Horizon was going and try to find something for it to fly by. And we found 2 possible candidates and chose this one to go to. To get information about it, we know nothing about it other than a rough idea of its size. There was a prediction based on its orbit. It was going to go in front of a star and block the light from the star. And that's what this little image is over here. We sent teams to different parts of the Earth's surface, different parts in the path of where the star was going to be blocked. And so you can imagine on the sky, this object here in red is going to be the asteroid. It's moving. And we watched the stars move along these white paths. And this one here, nothing happened. It just stayed the same. But this one here, it blinked off, and then it blinked back on again. And this one blinked off and blinked back on again. And this one, same thing. And so you get from these different paths of the single star seen from different points on the Earth's surface, you get a sense of what this object might be. And so here it's drawn as maybe it's 2 circles. Maybe it looks like this, a binary object. And you've got the bigger one blocking most of the starlight here, and then this one blocking this top chord. But it could also be an elongated object like this. As long as it goes all the way up here and all the way down here, you can do that with a single kind of cigar-shaped object. So there were great, great battles on the team between, is it a binary like this, or is it a single object but elongated like that? And what I'll show you is that both teams, both sides of that argument were wrong. It was neither a binary object nor a single object like this. It was something else. So, you know, it's limited by our imagination. This is what our imagination came up with ahead of time. And let's see what we found. So this is a month before we flew by this object. And this is a star field, and most of these are stars. And deep down here, I think it's that one, that's our target. That's where we're going. A tiny, faint thing. And so no chance to see what its shape's going to be like. And then we zoom forward a month. Hope it's in here somewhere. Let's see. Oh, it's a movie. Yeah, I forgot that. There it is. See it? That's as New Horizons approaches. You can see it just growing there, and as we get closer, it gets brighter and brighter and easier to spot. Looks like we're going to miss it, but that was deliberate. We don't want to run into it, so we very carefully chose the distance that we would fly by, that we get good enough images, but also have no threat to the spacecraft. Also, if you fly too close, your pictures close in get blurry because the motion of the object's too fast. It's like trying to take a picture of something really close up out of a car window, you know, as you zoom past it. If it's in the distance, no problem, but if it's close up, it's difficult to do. All right, let's move forward. I'm almost done. Let's see, so, oops, I'm gonna show you, yeah, here, we'll skip that other one. So this is the day before. So the day before we get to this object. This object's only 10 or 20 kilometers across, as opposed to Pluto, which was more than 1,000. So this is our best image the night before we flew past it. And this, when we smooth it out and filter things, that's the best we can come up with. And so the elongated object people were pretty happy here. They said, this isn't a binary, it's going to be an elongated object. Look, see how it looks elongated. And then, boom, that's what it looked like the night before. 21 miles, so 33 kilometers. You know, the people were still saying maybe these objects are two objects that are not connected, or maybe it's a long skinny thing. And then the best image from one day later is that. And so there it is. That's our object. And so it's not two objects orbiting each other, and it's not an elongated object. It's two objects that used to orbit each other and have touched down and merged. And so this is called a contact binary. So it's one object now, but it started out as two objects. So pretty fascinating object. We had no idea this is how it was going to turn out. And this is what the spacecraft showed us. So I think that's where I was going to end. Yeah, that's where I'm going to end. And thanks for paying attention and listening to Pluto's story. I'll be happy to take questions. Oh, I see Carter Ross there. Yeah, it's the river Styx. That's right. So the Styx is a river. It's thought of as a river, but she's also a goddess. You can't name moons after rivers. So the river Styx was how we connected to the underworld, and the goddess is the human form of the river, and that's why it's an approved name. So what is this object and what's it made of? So this object it's the most distant object we've ever visited. It's out 35 to 38 times the distance that the Earth is from the sun. It's mostly water ice, frozen ice. There's rock mixed in, so it's probably 3/4 ice and 1/4 rock all mixed together. We don't know. I mean, that's what we expect to be out there, and the data we have doesn't prove that conclusively, but it's consistent with that composition. Did Pluto capture Charon, or do they form together? Yeah, excellent question. So it's unusual for a moon to be so big compared to its planet, its parent planet. We talked about that early on. So Earth's moon is large compared to Earth. Charon is large compared to Pluto. And if you look at Jupiter, all of its moons are small compared to Jupiter. So we have sort of 3 different pathways, we think, to make moons. So for something like Jupiter, where all the moons go around Jupiter in the same direction, those we think all form together. So you make Jupiter, you make a disk of gas and dust that surrounds Jupiter. It's swirling around. A lot of it's pouring onto Jupiter to build up the mass of the planet. And the remnants of that disk are going in one direction. Those form into moons. So all those moons inherit the orbital motion of the disk. So they're in a flat geometry, and they all go the same direction. So that's forms with their planets. The second way are captures. You can imagine objects forming in independent orbit around the sun and being captured by the immense gravity of Jupiter. So those objects are far from Jupiter, and those are the captured population. And then these moons that are big compared to their planets, they don't fit either model. So neither of these two models explains Earth's moon nor Pluto's. And so for that, we needed a third model. And the one that's favored and does the best job at explaining both Charon and the Earth's moon is a giant impact. So for the Earth, we expect a Mars-sized object to hit the Earth, blast off material, and most of the material rains back onto Earth. It melts the surface, so it wasn't a good time to be living there. It would melt all the rock. You have a magma ocean. But some of the material reaccumulates in orbit and becomes the moon. And we think Pluto's moon Charon formed the same way. This is the only way to really get a big moon compared to the host planet and close in like Charon is with this impact. All right, good question. Let's see. Bright flash and watching Pluto occultations. This is Jean's Swank's question. I think the bright flash and watching occultation. So an occultation is a technical term for is watching a star and the star blinks out. So I think the bright flash there's a couple things it could be. I mean, so first of all, it could be referring simply to the star blinking out and blinking back on again. More likely, if the star goes right behind the center of the planet, you can get something called lensing. And so Jean will know this well. So you get gravitational lensing of light from a galaxy, a far distant quasar. You can get the light magnified by like a lens, like a magnifying lens. And the same happens for a planet with an atmosphere. If a star goes right behind the center of the planet, you can think of the light rays going out to the atmosphere of the planet and then bending and being refocused in one direction. And so you can get a brightening of a star. The star can be 2 or 3 times brighter if it goes into this central region. So maybe that's what the bright flash. Let's call it the central flash. And it works for gravitational lensings of galaxies, but also atmospheric lensing of light from a star. Any follow-up questions there on the formation of satellites or the bright flash? So now I'll go on to the next question. What's the distinction between planets and dwarf planets? And where are the other dwarf planets in the outer solar system? Are they all KBOs? KBOs are Kuiper Belt objects. So a dwarf planet is still a planet. That's why, so Pluto's not fully demoted. It's just got that dwarf put in front of it. And so the definition now is to be a planet, you have to be the biggest thing in your neighborhood. So Jupiter is the biggest thing in its neighborhood. Earth is the biggest thing in its neighborhood. And Pluto is not, because there's a half dozen other objects that are about the size of Pluto. And so then you become a dwarf planet. So there's a size limit before you become a dwarf planet. So there's a handful of them out in the outer solar system. And, these are going to change as we discover more objects. And the other place you can have dwarf planets is in the asteroid belt. So Ceres is big enough. There are other objects that are almost as big as Ceres, so it doesn't deserve to be a planet, but it's a pretty large asteroid and it's above the size limit for dwarf planets. So Ceres is a dwarf planet. I think Vesta, and maybe one more asteroid after that. So a few in the asteroid belt, and most of them are out there in the Kuiper Belt and in the far distant regions of the solar system. Pluto and the other Kuiper Belt objects are going to be icy in composition, just like this thing. Maybe 3/4 ice, 1/4 rock. And close in, the asteroids are mostly rocky because the ices aren't as stable close in near the sun where it's warm. So they have less ice in their compositions. We do discover ice in asteroids, but not as much. All right. Oops, I have more on polar caps. I wasn't going to talk about that unless I got a question though. But now I've seeded you with that idea. But are there other questions on anything? How did I do on time? Pretty good. Can you talk about some of the work I'm doing now? I'm doing lots of different things. So I sort of transitioned off the New Horizons team. Let's go back to, let's see, what do I have? Go back to here. Where's Pluto? There's my Pluto picture, so I went past it. There we go. Yeah, so basically I was on the New Horizons team and I was brought in, I discovered that moon with Mark Showalter, but that was my own sort of private project. And it's part of the reason that they invited us in to join the New Horizons team. Both Mark and I were not part of the New Horizons team originally. When we found this moon, they're like, hey, join up. So we joined up with the space mission. And I was brought in to do a specific task. And so the worry was, we're discovering all these moons around Pluto. The very worst thing after launching a spacecraft and waiting 10 years for it to fly across the solar system and get to Pluto is to have it run into one of these moons, right? So they took that very seriously. NASA was very worried about it. And they put together a team of people to kind of minimize the danger. And so I was on that team. And so we were basically tasked with choosing the distance to fly by or contributing to that conversation. All the instrument users on the spacecraft wanted certain distances for the flyby to get the best pictures possible. And then our sub team was saying, don't go this close, go at least this far away because you shouldn't see moons beyond that distance. We were also worried about rings. Rings are worse than moons from a spacecraft hazard point of view because a ring is composed of an innumerable number of small centimeter-sized pebbles. And when you're a spacecraft, moving 10 miles a second, you run into a centimeter-sized rock, it's going to just take out the spacecraft. So it'll destroy the spacecraft, that energetic. So the very worst thing you could do is run through a ring. Of course, running into a moon's no better, but that's less likely. And so we did a lot of simulations on where moons and rings are stable, and a lot of discussion of where the distance the flyby should be. The spacecraft could do some other things as well. It could spin, and it has a sensitive sensitive side and a less sensitive side. So it could rotate so that the less sensitive side was going first as we cross over where a ring might be. So that was in our purview as well, as to decide whether or not we should rotate the spacecraft. And it's always trade-offs. If you do that, you don't get as good. The data you get is not as good. So do you give up on some of the data you're going to get, the best data you might get, to protect against a ring that you don't know is there or not? So in the end, we chose not to do that. But if we'd been more worried, we would have. So we chose the distance, we chose the orientation of the spacecraft, and the flyby was perfectly successful with no rings and no new moons discovered. So we had a safe flyby. And then I did the same thing for the flyby of the next, the asteroid, Arrokoth, it's called, the Kuiper Belt object. We also were worried perhaps it has a satellite or ring particles. And so we chose the distance for that. So that's the end. Then I transitioned off New Horizons because there's no more hazards to help them with. And so they're now just flying out into the distant part of the solar system and taking pictures of objects from a great distance. And so I'm watching that with interest, but no longer actively involved. And so I'm working on a mission to Jupiter and a mission to an asteroid called DART. And so these are two new spacecraft missions that are coming up. Any theories on the UFOs we are seeing? Who's seeing UFOs? Marianne, you're seeing UFOs? You gotta step up and unmute and tell us about this.
Well, the pilots, and haven't we as the government admitted that it's not some strange phenomena located in New Mexico?
Okay, so you've not seen one. I want to make sure we're gonna.
Oh no, I haven't. No, yeah, I barely.
All right.
Yeah, I'm nearsighted. Remember.
All right, that's. Every single UFO that's been seen, so UFO is unidentified flying object, and so many of them are linked. They become identified flying objects if you can explain them. So many of them are linked to declassified military hardware. So some are weather balloons, some were I think the stealth bomber, when they were testing it and not yet admitting we had it, and going back to the 60s, there are other military projects that the government won't admit we have the military project, and so they just classify it as an unidentified flying object. And so there's been, but to jump forward, there's never been an example of an unidentified flying object that has that we've proven has no other explanation than an alien spacecraft. So in my mind, there's no evidence for alien spacecraft yet. There could be. Someday we might find one.
It's a bummer.
Bummer. It'd be very well. Like, if you're a conspiracy theorist, the government's got one, a crashed one in Area 51, hidden away and not telling us about it. But the government can't even hide its Watergate scandal, so they're not going to hide an alien spacecraft and not have someone leak that out. All right, let's see. How far will New Horizons go before it runs out of power? So you go that far out in the solar system, no solar panels because the light from the sun is just incredibly faint. You'd be down at 1/10% of the brightness at Earth, and so that's almost nothing. So it's got a nuclear power source, and so it's called an RTG. NASA likes its acronyms: radio thermal generator, radioisotope thermal generator, something like that. And so it's basically a lump. Oops, Jean's got the right title there. I saw Jean speaking, but she's muted as well. At any rate, it's a lump of radioactive material, and it's hot, and so it radioactively decays. It's warm, and use that warm temperature to generate electricity. And so the isotope they use is, forget what it is, but it has a half-life of maybe 20 years. So in 20 years, the spacecraft will have half as much power available to it as it does today. And so what will happen is it's a slow death because, we'll turn the cameras off. There's less power today than there was 5 years ago, and there's less power 5 years ago than when it was launched. And so, but there's also fewer demands on the spacecraft. We don't need the cameras anymore. And so as we slowly lose power, we'll slowly turn off instruments and save the power. And it'll probably keep it going for another 20 years, something like that, maybe even more. I think it's radiothermal generator. I should know that. All right, any other questions? I can tell you a little about this ice cap if you want, or we can all break if we've had enough. What time is it? It is almost an hour. So never, as a speaker, you never go more than an hour. So that's the cardinal rule of public speaking. Everybody's interesting for a while, but nobody's interesting after an hour. So I think we can end it, and people that want to leave are free to leave. And I'm happy to stay and answer questions as long as anybody wants to stick around. That's sort of the best way to handle it. And that way, you're not it's not rude to leave at this point. It's the point. That's what we're saying. Why is Pluto's ice cap at 30 degrees? I did see that question. So here we go. Why is it there? Let's go, forward. How do I guess I hit the back button. Yeah, I have a few more slides on that. So I worked on this as a science project. So I'm a dynamics person. So it's the subfield of astronomy. There's observers and there's theorists. So the observers do what you think astronomers do. They go to telescopes and look at things. I do a little of that. Mostly I'm a theorist, and I sit in a room and I try to figure out how things work. And so it's more fun than that, but it's a lot of so I do a lot with orbits and dynamics, motions of objects. And that's why I was brought in to help with the moons and the rings for possible moons and rings at Pluto. So this project was interesting because it's not really dynamics, a little bit out of my area, but it combines a lot of geology and geophysics and ice physics and stuff like that. And so here are our ice caps. And let's see, this is Antarctica on the Earth. You can see the tip of South America here. That's Australia. And so most of the water on Earth is locked up in that ice cap, in the Antarctic ice cap. I guess most is in the ocean, but then of the solid ice on the Earth, most is in the Antarctic ice cap. And then here is the Arctic ice cap. And so you got Greenland with a permanent ice cap on board, and then you have this just floating on the ocean, right, and blocking all these passageways through the Canadian Arctic. So when the British tried to find the Northwest Passage, they sent their ships here in the 1800s, and they tried to find their way, across over here, over to Hawaii. They wanted to get to Hawaii, and North America's in the way, so they tried to go through here, and they get blocked by the ice. And there's the polar cap on Mars. So it's got these really interesting, swirly kind of features. It's mostly frozen carbon dioxide, and at the very center, there's a lump of frozen water as well. So the thing about ice caps is what they care about they care about how much energy is coming from the sun. And so for both the Earth and Mars, the polar regions get a lot less sunlight when you average over a full year than the equatorial regions. That makes sense. That's why the equator is hot and the poles are cold. Ice caps also care about where it's light and dark. So if you imagine Mars here and you want to form some more ice, here's a dark patch and here's a light patch. So the dark patch absorbs all the sunlight, right? Dark objects absorb light and bright objects reflect light. So this dark region here absorbs sunlight and heats up. And so if you're trying to form more ice, that's the last place you're going to go because it's too hot. But over here, it's sort of dark. It's brighter, and so the sunlight hits that whiter region and it reflects. And so a lot of that reflects off into space, and the small amount that is absorbed leads to less temperature rise than over here in the dark region. So if I was building up this ice cap, this is where I'd put the ice next, over here where it's bright, or on top of the other ice that's already there. And this dark region will stay ice-free for the longest time. And it also cares about topography, and you see that really clearly here for the Earth, right? So Greenland is mountainous, and so the North Pole is up here somewhere. And look how far south the ice goes when it's sitting on a continent, because it's up high, and so that's colder when you're up high. It's easier to snow out and create ice that's permanent on top of a landmass. Here you're in contact with the ocean, so you're always just barely hovering above or below freezing if you're the ice. And so this region melts away more easily than the region that's on top of a continent. So these are the kind of things you have to think about of where ice caps are going to form. Okay, you care about sunlight, light and dark regions, and topography. And let's see. And so this is a map of Pluto. We've taken that picture of Pluto, we've unwrapped it and made it into a flat projection. And so you can see it's very interesting to do this with a spacecraft flyby, because this is where the spacecraft was close, and we see this region very, very clearly because the spacecraft was right on top of it when we took those pictures. This region out here, the spacecraft was 3 days out. Pluto takes 6 days to rotate. And so these images here that are all fuzzy, the spacecraft is so much further away that you don't get as clear of a view. So you can tell there's some sort of crater here. It looks really interesting, and you wish you had better imaging, but the imaging is only good in this one hemisphere, basically. And so the thing about Pluto is this is not at the pole. It looks like an ice cap like you see for Earth and Mars, but it's at Florida's latitude. And so you can take the tilt of Pluto. Pluto is tilted by 120 degrees. There's a spin axis, and you tip it over to 90 degrees, and then even further. But it's tilted, extremely tilted. And when you work out, as I've done here in red, I've worked out where the energy goes from the sun when averaged over a year. So how much sunlight goes to the poles, how much sunlight goes to the equator, how much sunlight goes to different latitudes. And so what I've done is I've drawn this trace here as how much sunlight goes to the different latitudes. And so cold is on this side and hot is over there. So more sunlight on Pluto goes to the poles. The North and South poles get more sunlight averaged over a year than the equator does. And the reason for that is Pluto is so tilted over that over times in its orbit, the pole points almost directly at the sun. The sunlight shining directly down on the North Pole. And so that's high summer in Pluto, and that more than makes up for the fact that in the winter can't see the sun at all. And you average over a full Pluto year, the poles get more energy, more sunlight than anywhere else on the planet. And the equator gets almost the least amount, but not the least is actually right here. And look at that, it's at 30 degrees, plus and minus. And that maps over to kind of the center of this ice structure. So part of the answer is, well, this is where it's coldest on Pluto. And so it's, you can ask why there's not another one at minus 30 degrees. We don't have a lot of data from down here. You can ask why there's not more along a full line. Anywhere along this line I'm tracing out right now, that should be roughly the same temperature, but it all forms right here. And so there's a lot going on. This is the coldest region of Pluto, so that's one part of the answer. Another part of the answer is, if I have an atmosphere and I'm trying to make more ice right now, I'm going to go to this dark region here, because that's absorbing sunlight and heating up and staying warmer. And over here, we've got a bright region, which is reflecting most of the sunlight. So once you start an ice cap, you build up the ice in that location. It's a favorable location, and over time, the ice will migrate to that favorable location. So that's probably the answer. For whatever reason, this was the best place to start the ice cap. Once you start it, you make that part of the planet's surface bright. It reflects sunlight, it stays colder than the rest, and then the ices just continue to build up there. And so that sounds pretty crazy, but it really makes sense. The ices are there because the first ices went there. And you might go back and say, well, why is that? Why is that not the case on Earth? Earth has 2 polar caps. Why don't the ices go to the best place for ices to go on Earth? And my counter to that is that it has happened. So if we look at how much ice is in the north here and how much ice is in the south we have a continent of Antarctica. It's raised pretty high above sea level. And so it's a great place to put ice. And so most of the frozen water on our planet has migrated here over time. And so this is like 95% of the world's ice, and only 5% is up here. So we really, we see 2 bright regions. They look about the same size, but if we add up the mass of the ice, it's almost all in Antarctica. So the best place for the ice has figured it out and gone there. And the same happened on Pluto. So there's more to the story, but that's kind of the part that's easiest to follow and most interesting, I think. The part that's not explained, well, the other mystery is so you wonder about the different longitudes here, right? And this longitude, what's special about this longitude is directly underneath the moon Charon. So this ice cap points straight at the moon. How does it know? How does it know to do that? Is that just chance? I think the center here is 5 degrees off of perfectly underneath the moon. Pluto and Charon are synchronously locked. So our moon keeps one face towards the Earth. On Pluto and Charon keeps one face towards Pluto, and Pluto keeps one face towards Charon, because both objects are so big, they've had time to slow down into that configuration. And so the side of Pluto, if you're looking at Charon, you're in the center of this ice cap. And if you're on Charon looking directly at Pluto, this is what you're looking at. And so it's figured out. Somehow the ice cap knows where the moon is, or the moon knows where the ice cap is. Or it's chance, but it's, as I say, it's 5 degrees off, so it's sort of a 1 in 40 chance, something like that. Or not 1 in 40, did that wrong, 1 in 70. Other questions? I'm talking about ice caps. We can talk about other things too. Let's see.
There are a couple in the chat, Doug.
My chat didn't scroll. I think I got them all, didn't I?
Well, look, the one about we're interested in DART and what that is and what you're doing with it.
Oh, what is that? Did I miss that one? I went straight to the UFOs, I guess.
Yeah. Yeah.
I don't see a DART question.
Well, it reads.
Oh, there it is. Yeah.
So you could put up your DART screensaver.
All right, let's go do that. We were going to talk about screensavers. Where is that? I don't see it now. There. Video. There it is. Okay, so choose virtual background. So there's my Mars one. I showed some of you my favorite background. This one's here. This is my space kitten, right? Little kitten wearing a spacesuit. Isn't that cute? All right, I think it's cute. And let's see. Here's the Mars helicopter that just landed. So that's the first time we've flown something on another planet. And there's my DART background. So the DART background, it's this asteroid here. And there's a spacecraft, and here's another asteroid. So it's a binary asteroid, double asteroid. And DART stands for double asteroid RT. Oh my gosh. Double asteroid. I'm working on this mission and I'm blanking. Hang on a second. Redirect test. And so what we're gonna basically do is we're gonna send this spacecraft all the way to this little asteroid, And I should tell you how big these things are. This one's about a mile across. That's the big object. And the moon here is only 100 meters across. So it's a house size, a big house. So building sized. So these are tiny objects as these things go. Double asteroid redirect test. So the spacecraft is going to fly straight, unlike New Horizons, we're going to fly straight at this moon, and we're going to hit it with the spacecraft. And so the whole purpose is to hit it with the spacecraft and give it a little push. And then we're going to measure that push and see how much we've redirected the asteroid, how much we've changed its orbit. And so this is sort of the, I'd say it's the second step in trying to defend the planet against large impacts. So large objects will come and strike our planet. One killed the dinosaurs 65 million years ago. One landed in Russia, much smaller one, just 10 years ago in Chelyabinsk. And so these asteroids that strike planets, you know, they've caused mass extinctions on Earth many times over the Earth's history. And so we're at an interesting place in our technology in that we're almost able to protect ourselves against this threat. So first of all, the threat's kind of hard to assess because the really dangerous things come in only every 1,000 years or every million years. And so you can kind of just say, well, every million years, what are the odds? But you know, every million years, when that object hits, it can kill off the entire human race, right? All it has to do is punch through the atmosphere, strike the planet, blast enough material up into the atmosphere. It blasts molten rock into the atmosphere. The molten rock lands all over the world. So glowing, you know, 2,000-degree chunks of rock landing in all your forests. So it lights up all the forests burn down, all the smoke goes into the atmosphere, and you shut off the sun. And then you kill off everything pretty much. And so it's, you know, it's once in a million years, but it's so devastating. So how do you worry? How much do you worry about that? Do you say, it's not going to happen in the next 100 years? Or do you say the consequences are so devastating, we got to do something about it? So we've not really answered that question yet. So what NASA directed astronomers to do many years ago was go out and find these objects in space. Let's figure out how bad the problem is. How many are they? Where are they? You know, flag them if they look dangerous, if the ones that are on orbits that'll cross Earth's orbit. And so we've pretty much done that. We found objects down to maybe 100 meters in size, maybe 200 meters. And so most of the objects that are super hazardous to us, we can safely say they're not coming our way, at least not yet. The next step is, if one is coming at us, what would we do? And so right now, the best we can do is say, it's going to hit in China, so everybody evacuate China. Right? That's about the best we can do. But if it's big enough, it's not going to matter where you are on the planet. But certainly you don't want to be where it's going to land, because that's ground zero is the worst place to be. So if the idea is, if you can redirect it, if you can find this thing far enough in advance and go up with a spacecraft and nudge it to the side, you can prevent it from hitting the Earth. And so we almost have the technology to do this. We have the rocket ships, we have nuclear weapons, which might be part of the answer. But we don't know what happens. When you run into an asteroid, we don't know how much the push is going to be. And that's really important. So that's what this test is about. We're going to send the spacecraft. We know the properties of the spacecraft. We hit the moon. We know its properties, and we're going to see how much the moon gets pushed. And for those of you that do physics, it's a momentum problem. We know the momentum of the spacecraft. When it hits the moon, we know how much momentum is added to the moon. So it should be a solved problem, but it's not, because you hit and you blast a crater and you kick off a whole bunch of material like a jet. And that jetting makes your strike more effective, because that jetting helps push the asteroid in the direction you want to push it. And we don't know that. We don't know when you hit with a certain size mass on a certain target, how much jetting of material you get, how much material gets blown off, and how fast does it go, and how much of a push does it give. So that's what this mission is trying to figure out. And it's coming up fast. It's launching in November, and it'll be getting there in about a year later. So you'll be reading about this in the next couple of years as it happens. So it's crazy. We're living in interesting times. Oh, the favorite background is the cat is my favorite one as well. We're going to go back to that one. It's just that good. So I'm going to give some more information about the space kitten. Where's my space kitten? There we go. So I'm going to step aside, or I'll step back. So of course, there's a space station that the space kitten came from, and there's Earth down there. There's our kitten. I'll just step out of the scene. And so my favorite part, so he's waving hello, right? And you just note the tread there on the spacesuit. So that's for traction, so that the kitten can work with this, the space tools and do space tasks. And so I thought that's the best part. Oh, thanks, Corey. Fabulous presentation, says Corey. Wow, that's great.
It was fabulous, Doug. Thank you very much. Really very interesting. I'm lucky enough to know where Doug lives, so I can always go ask him what I'm seeing in the sky. So that works out nicely. We really appreciate it. Thank you. And for everybody, this will be recorded and you'll get a link to the recording. Please feel free to share it with anybody. And then we'll look forward to seeing you on August 28th with the poetry selection. And then we will be getting the fall calendar out in the next couple of weeks. So appreciate you joining us. Have a good rest of your weekend. And thank you again, Doug.
Oh, thank you. Thank you all. Thank you for the audience and the good questions.